What's going on, everybody? Welcome back. Going to be picking up on where we left off with a retro game. And now that we got all the kinks worked out, I'm expecting this will be a lot better. That is Amsterdam. I miss that place. Interesting. Looks like the YouTube stream's a little laggy. Oh no, that's just me. I'm just behind. Okay. Maybe turn the fan off though. Oh, good call. All right. I'm going to get situated real quick and then we'll get going. So let's get into it. We're going to boot up the Pico 8. I will try to angle my microphone away from the server rack. I understand it's a little noisy. Not ideal. What can you do? All right. So I added a Git directory because I finally tracked down where Pico saves these things, which you can find if you just type folder. And then in another window, that should open up where these are actually kept in the file system. So, good to know. We're going to load up our game. Okay, and when we last left off, we made some good progress with a little parachute guy. We even gave him the ability to sway. And we added some clouds. And I think the final struggle of the day was we were trying to figure out how to dynamically add clouds to the game and then like take them out when they get too high. So update got a little complicated here. You can see we're iterating. This is just the general pattern I set up, that every object that was supposed to be like rendered and managed in the game, I was adding it to this OBJS global, and then I like to call update on each one. And then here's where I was trying to get it to remove clouds, and I think, yeah, we are either adding clouds way too quickly or they're moving too quickly. Kind of stresses you out just looking at that, right? At least the motion works. Our little guy sways. He can move diagonally. Good stuff. So I think I would like to, instead of dealing with individual clouds within our main update loop, I had a shower thought where I like to create sort of the concept of like a cloud machine that would kind of just handle all this for us. So that way the cloud machine could, we could tell it how often it should add a cloud. It can keep track of the ones it's supposed to be deleting. Let's try it out. So let's see. I'm going to follow our pattern, make cloud. I'm going to do make cloud machine. Cloud machine. And then it looks like in these, I like what we've been doing so far, where the public API, we stuff it in this little variable called O, and then we return it at the end. So we're going to go local O, return O, and then each thing that we're adding to this object loop should have an update for like updating game state, and a draw for like the hook on like what it actually needs to render to the screen. So let's add those straight away. We're gonna go function. How were we doing that before? Okay, function o dot draw, function o dot update. Okay, cool. And now we can keep local clouds in its own little variable here. And let's see. I think we can keep this around. I like this little make cloud because our cloud machine can call this. But I have a feeling that the individual clouds are not going to have to like, well, I don't know. We'll see. Yeah, we'll leave this around. That looks handy. So each flag will have a .destroy bit that it sets to true if it goes out of bounds. Let's try keeping it around. All right, so on updates, this thing should first just add a cloud to its local clouds list. Let's Google that. It's pretty easy. There's an add function. Okay. We'll go with that. So on update, this should just do add clouds and then make cloud. And check it out. So now we can get rid of that. And instead of adding each individual cloud in a loop, we're just going to add OBJS make cloud machine. Draw the background. And then this is where we call draw on each object. Nice and generic. And then I think we're going to get rid of this, since now the cloud machine is going to handle all of that. And get rid of this too. Yeah, we definitely don't want to just add a cloud on every tick. We're still going to have that problem, but we'll get to that. All right, so draw is looking about as simple as you can get. Clears the screen, fills everything blue, and then draws every object in our list of objects. Update, don't have to deal with the screen because this is just game state, and we're doing the exact same thing. We're just calling update on each thing. Okay. And now we just need to call draw. Within this draw function of the cloud machine, we just need to call draw on each individual cloud. So that will actually look a lot like this. For I object in I pairs, do object draw. Okay. For I cloud in I pairs clouds, do cloud draw. All right, cool. So at this point, we should have successfully moved the problem we created just into a new concept we made called the cloud machine. Let's run that. Okay, interesting. So the clouds are just appearing now. Oh, I'm going to start my timer while I just thought of it. Did a lot of coding last night. It wasn't good for the back. Okay, so our clouds they're getting spawned, but they're not moving. That makes me think we are not calling update on them. Yeah, okay, so we're just adding clouds. That makes sense. We're not actually calling update on the clouds. Okay, so for I cloud in I pairs clouds do cloud draw update or an update. And now they're moving. I like how smoothly they're moving too. Look at that. Oh, interesting. They're all getting stuck up at the top. It looks like upside down snowing. So obviously the other problem with this is we're just adding clouds to the screen. I'm guessing we would eventually crash the game because you can't just keep adding data to it infinitely. It's keeping track of where all these clouds are. So let's try to make the delete. So as part of this, we want to, after we're done updating all the clouds, we want to go through them one more time. And for each cloud that has its own delete flag triggered, we should get it out of the list. So for I cloud, and maybe we could just do it in the same list. Let's try that out. If cloud delete we called it destroy. Then remove clouds cloud. And we have an error. Runtime error. Attempt to call global remove. So it must not be called remove. Delete from table. Oh, I don't want a video. Delete function searches a sequence in a table and deletes it as expected. Okay, so we actually want to call delete. It was del, not delete. There we go. Now we don't have any clouds at all. What happened to them? Where did they go? If cloud.destroy, then delete clouds cloud. So on update, if 0.y is less than 0, o.y is less than 0. Oh, there it is. We're defaulting destroy to true. That was dumb. There, we fixed it. So now we're kind of reaching a better equilibrium here. We don't have clouds bunching up at the top of the screen anymore, but it's still, it looks like they're spawning unnaturally. And I think that's because of two reasons. One, it's because we randomized the Y location that they can spawn. And now that I think about that, we only want them to kind of like appear from the bottom to sort of help the illusion that we're moving through the sky. So the way I see it, we pretty much always want them to spawn at the maximum Y coordinate to make it look like they're coming up from the screen. So let's see if we fix that. That looks better. Beautiful. All right. And we still have way too many clouds. It looks like it's beautiful, but it doesn't look like what we're going for. So I think we need to figure out a way to control how often we actually add a cloud to the list, and that way we can tweak the frequency. So I have a feeling it's going to involve a random number, kind of like what we're doing here. So why do we do this? I'm going to make a little function called should add cloud. And that's just going to return the result of like a random number, because I think that's the best way we can control the frequency. We can say return, so RND is equal to 1. I think that should do it, because the RND function will return us a random integer from, let's read the docs for that. RND. Generate a random number between 0 and the given maximum. Okay. So it'll be between 0 and the given maximum. That means it'll be between, the choices are going to be 1, 2, 3, and 4. So this should be a 25% reduce in clouds, because it's going to get a random number, and if 1, 2, 3, or 4 is equal to 1, then we're going to tell it to add a cloud then. So this is going to be if should add cloud, then beautiful. We don't have any clouds. Where did they go? What happened? If should add cloud, then add to clouds, make cloud. Should add cloud, random 5 is equal to 1. Oh, does this return? Oh, it's returning decimals, that's why. Okay, so I think random is returning a decimal, not an integer. So we need to, as the examples say here, like if you want to emulate a dice roll, which is most closely what we're doing, we want to take the floor of that. Easy. Floor. There we go. I love that. So now we should have a good way to control like how sparse it is. So like and like that. 8's kind of nice. What does 10 look like? I think 10 is kind of where that's the sweet spot. I mean, we don't want them to be like so distracting. This is kind of relaxing. Cool. And how about we'll go for bonus points? And I would like to add a param to make Cloud Machine that can control the density of clouds. So we'll say density is equal to 10. Density. Nope. I wonder if you can do default parameters in Pico 8. Or would that be a Lua thing? Parameters. I have a feeling that this isn't possible. So, how about instead we just make it a variable here. Local density is equal to 10. I mean, that way if we have to modify it, at least it's just right there. I mean, we'll know to go to the Cloud Machine. Cool. I'm very happy with that. fun. All right, so we need to make some bad guys. So I think where I was going with this game, you're coasting down, you're coming down in your parachute, and I wanted to. Oh, interesting. I just noticed a little bug. How about before we get to that, we fix this bug? The player is always swaying. You cannot not sway. Let's see what's going on in the player. So this is our player. Sway is set to 0, and then there's our code. So if it's set to 1 if you're swaying to the left, 2 if you're swaying to the right. That's the sprite number. I have a feeling it's because we never actually set sway back to 0. Yeah, here it is. Okay, so if button presses 0, sway is 1. And then we move the player. If button presses 1, sway is 2. We're swaying the other way. Move the player the other way. I think we just need an else. O.sway is equal to 0. Beautiful. All right. I think I'm going to start to make some bad guys now. Things that our parachute player needs to avoid as he's coasting down. The easiest I can imagine is probably a balloon. I'm going to make a big red balloon. And let's see if we can make this look natural. A really big balloon. There we go. Okay, that's looking a little better. Unfortunately, we don't have a lot of room for the string. That's kind of what I was looking for. No. I don't know. It looks like it could be a balloon. That's good enough. We'll try it. And you know, it would be kind of fun if we'll get to this eventually, but I like to set up 2 sprites like this so it sort of looks like the string is flapping. That'd be sort of fun. But let's try to get it working with just the simplest use case first. Okay. So similar to our cloud machine, we're going to have a balloon and a balloon machine because we want to throw something in the object loop that just knows to generate balloons. Make balloon. There's our general boilerplate. And we are going to want to draw the sprite to the screen, which is the SPR command. And then we're also going to need to give it some coordinates. Okay. Actually is going to look a lot like a cloud because we're going to, you know, as this balloon passes off the screen, we're going to want to give it a destroy flag. That's a good idea. And we're probably going to want to randomize the X coordinate. Cool. Let's give it an X, which is going to be randomly generated from 128. Let's give it a Y, which is going to be fixed at 128. Let's give it a destroy flag that defaults to false. And then in draw here, it's going to go SPR. We're on sprite number 3 now. Counting. No, we're on sprite number 4. 1, 2, 3, 4. Sprite number 4. Let's look at the documentation to make sure we get the args right. SRP. Sprite number, X and Y. X and Y. And then the only thing it should do on update is, using our cloud as an example, if the Y coordinate passes from above the screen, it leaves the screen, then we're going to just flip the destroy flag to true. And then we decrement the Y otherwise. Easy enough. Easy enough if I don't get lost. Here we go. So if Y is less than 0, then destroy is equal to true. Else Y minus equal 1. And I think we're doing things a little differently. In the cloud example, I had all these coordinates pinned to this object here. Let's try to keep it more scoped. I don't think, I mean, the goal is that nothing else needs to look at the coordinates except for the object itself. You know, it should like already know what it's supposed to do. So if I like that pattern, maybe I'll update the cloud as well. All right. Now we're going to need a balloon machine. Make balloon machine. It's going to have its own little object, which we'll treat as the API. It's going to have a function called draw. We should be pretty good at writing these by now. For I, I'm just going to do B in I pairs balloons do end. And that's going to be B draw. B colon draw. It's going to keep track of its own little balloons list. It's also going to have an update that's going to sort of do the same thing. For I, B in I pairs, balloons do end, B update. Density. I'm just going to guess and say we only want like 50 because we don't want to make, you know, kind of like the clouds. This is the number that we'll use to control how often it spawns a new one. Also, that gives us a nice little lever we can pull later if we want to make the game like increase in difficulty. Like the longer you hang in the game, the more balloons you have to dodge. That'd be kind of fun. Should make new. I'm going to return floor of the random of density, and that is equal to 1. So after we'll do the spawn first. I'm all over the place with indenting. If should make new, then add to balloons make balloon end. And then here we'll do if b dot destroy then we're going to delete this B from our balloons table. Else, if the balloon's not supposed to be destroyed yet, we will just go ahead and update it. And FI, not writing bash. All right. So this balloon machine, it's going to add a new balloon only if our randomize function passes, which should pass 1 out of every density times, density being 50. After we decide whether we're adding the balloon, we iterate over them. If the destroy flag is flipped, we're going to delete the balloon, otherwise we're going to update it. We got some clouds. I think I forgot to do something with the balloon machine. Oh yeah, I definitely have to add it to here. Okay. So we just have to do this. Make balloon machine. I don't see any balloons yet. Just in case it's because of the density, why don't we crank the density up to something ridiculous? How about just 1? We should just be covered in a smattering of balloons by now. We're not. Something bad happened. Okay. Let's step through it. So on update, if should make new, add to balloons, make balloon. If b.destroy, then delete the balloon, otherwise update. Let's look at the balloon. Is our sprite wrong? Should it be 3 instead of 4? No, that didn't look like it was it. If y is less than 0, then destroy, else y minus equal 1, and y starts off at 128. I hate to say it, but maybe it's because we try to get fancy and leave x and y and destroy outside of the object. I don't know how scoping works in the Pico 8. Why don't we try doing this? Print x. How does the print function work? String x and y. X, and then we're going to just print this at a fixed spot. So how about just 0, 0. Looks like that's never getting called. So make balloon. Make balloon machine. It's got its balloons. There's an update. Here. Interesting. Let's see, do we get here? Oh, the color to use for the text. Maybe we just need to pick a different color. One. 2. Oh, it's because we're running this after rectangle fill. That's why we want it to be down here. Print here. No. There we go. Okay, so now it's showing. We just need to print it as 1. So I'm going to steal this. We're going to cut it. Now that we have a debug that's working, we can plop this into... Let's see if Balloon Machine Update is getting called. Balloon Machine Update is not even getting called. Well, it's time for a coffee break. I'll be right back. We're back. Alright, when we last left off, we had some kind of bug where despite all the work we put into our new balloon generator, we got no balloons. And we are trying to find out, we are just trying to find a line of code that's actually being called. So let's be a little, we're in dire straits. Let's just test the basics first. Not that, I copied my link. Alright, so this is never getting called. Make balloon machine. That's a problem. Where do we think we're calling that? Make balloon machine. Adding it to objects. Let's see if we're calling here. Oh, because we wouldn't see that here anyway, because init is only called once. Back to the basics. Okay. And actually, I'm going to do this. We're going to make a global just called log, and then we'll always print it. And log, we're going to set it up at the top here. All right, cool. Like that. You concatenate strings. Oh, I think I actually know how to do that. It's just dot dot. It's weird how it's just stuck on 3. Yeah, is it just me or is I just set to 3 all the time? Let's see what the iPairs function does. Returns an iterator of index value pairs for all elements in the table. For in. It says it should print the index. Interesting. Well, at least log is working. Let's find where it's busted. Okay. Let's first make sure that just, this is getting called down here. Log equals here. Okay. So that is called. So next we step into make balloon sheen. We're going to go into here. Log is equal to here. Still there. Okay, we are definitely there. This is a much better way to log, I think. It's easier just to set a global variable than to worry about like what order it gets drawn on the screen. Let's see if it's returning here. We're there. So let's make sure that update is getting called. Here. Still good. Oh, this will be interesting. Let's see if it ever actually makes it to here. true. Okay, so I think I found the problem. It is that our function is never actually returning true. The should make new. Should make new. Return floor, random of density. Oh, okay. I wonder if we broke it when we tried to set the density to something else. Because my first guess was maybe floor random of 1 is never equal to 1. Okay, so that's no longer the problem. That was a problem, not anymore. So once should make new is true, we add the result of make balloon to balloons. And for I be in balloons, if B is equal to destroy and delete balloons, let's see if we ever get here. That's never true. So it looks like we don't even have any balloons. Pico 8 get list length. Count the non-nil entries in array. I think that's what we want to do. Okay. Why don't we see what the count is each time we call update? Interesting. You can see all our balloons there. We're up to 11, 15, 17, 18. It looks like they're never actually getting deleted. That's not good. Why aren't you deleting? We have balloons. If b.destroy, let's see what our balloon does. Okay. So if y is less than 0, then destroy is equal to true. Else y is minus, okay. Oh, duh. Here's why. It's because we're calling balloon.destroy, and within balloon, destroy is just a private variable. We're not actually attaching to the object. So here it is. We're going to fix the world right now. Didn't fix the world, but that's something new. Unexpected symbol near dot. Local. Oh, it's not a local anymore. Duh. Would have been a lot cooler if I got it right the first time. Here. Now we fixed the world. Kind of. We fixed that, but there are still no balloons showing. All right. Let's see. I liked when we could see how many balloons we had in our list. Why don't we put that back in? Log equals count balloons. I like this. So you can kind of see at first it was just growing, and now we're hovering around 13 to 17. That's good. But we still can't see any balloons. I wonder if I got the sprite wrong. I can never remember if it's 0. Oh, maybe this is telling me. Yeah, 0, 0, 3. So 0, 0, 0, 0, 0, 1, 0, 0, 2, 0, 0, 3. We have 3, right? Oh, we're calling sprite 4. So we had the sprite wrong, too. We got balloons. Okay, so to recap, we were not exporting the destroy attribute, and our balloon machine couldn't access it, and it was always rendering as false. We broke the density, probably, so it was never going to return true anyway. And we were calling the wrong sprite. Lots of stuff was wrong. That looks like way too many balloons. Now we can step down the density a bit. I'm looking for like one every once in a while. That's kind of hard to avoid. I think it's a good start. We can go down to 30. Let's act like we have to avoid these. The balloons can kind of be the easy ones because they sort of move as fast as the clouds. We could also like randomize their speed. That would be kind of fun. Let's increase their speed. See what that does. I'm going to add another attribute for speed. Let's make them 2. And we want that to be an attribute of the balloon, I think, not the balloon machine. Speed. Now these things are zooming. I like that, that's fun. Alright, so now we need to make something bad happen when the player actually hits a balloon. And I think that'll be the last little push we make. This is a good session. We got a lot of stuff done. So when the player hits a balloon, we let's just play a sound. I think that would be kind of neat. We haven't played around with the sound editor yet, which, to be honest, I'm not too good at either. So that'll take some figuring out. Okay. So we need to detect when the player is on top of a balloon. I have a feeling that the Pico 8 doesn't provide anything special for like detecting collision. I think you just need to like compare the coordinates. Yeah, there's a Reddit thread here. Easy way to do collision detection. Tutorial series. You don't have time for that. I think we might be able to use the concept of flags. So the Pico 8 gives you these flags here to basically just do whatever you want. Like they're just sort of switches to say, like, you know, you can just dynamically look at a sprite at a location, and then if the flag is, you know, set to true. What I'm thinking is we could, for all the sprites that could hurt the player, we could designate the first flag as like, okay, this is a bad thing. And if you're on top of it, then you should, you know, react to it, like play a bad sound or lose a life or, you know, shrivel up and die. And I'm thinking, because we're sticking to the very object-oriented method, I'm thinking it's going to be the player object's responsibility to check its own position and say, is there anything bad here? Should I be reacting to this? If sprite Pico 8 functions API. Let's just look at the whole API because I think we're going to want to just glance through. It's probably going to be in graphics. If sget means sprite get, that's exactly what we want. Gets the color value of a pixel on the sprite sheet. No, not quite. We only care about the color. What is SSPR? Draws a rectangle of pixels? Nah, not quite. I shouldn't have closed that. fget gets the value of a flag of a sprite. So n is the sprite number, and the flag index 0 to 7. Okay, so this just returns the flag value. So like if you like already know that you're dealing with sprite 4, then you can just get the value of that. So that's, we still need to figure out if we're on top of a sprite. This could be tricky, because I think the standard library like doesn't give us anything easy. Like I think within our top level loop, like we have everything split out really nicely, where we have like all these little objects that are sort of doing their own thing, and they each have their own draw and update. I think we may need to handle some collision within like our top level update, because we have all these objects that are getting updated independently, but the way we've written it, there's like no way that they can know what each other's doing, which stinks. Also kind of a fun challenge though. mget. What does mget do? Gets the sprite number assigned to a cell on the map. This function only works when the tiles are drawn by map function. Oh, okay. So this would be a lot easier if we use the map function to draw stuff, which I've played around with the map a little bit. I think that has to do with, where's all the map stuff? Is that here? Yeah. So this is what you would use if you were drawing like, you know, like a whole level of Super Mario. And we're doing it the cheap and easy way, where we're just filling in the whole map with a blue rectangle. But as a result, we're also going to have to deal with the collision ourselves. Okay. So minimally, the player needs to know where the balloons are. I don't want to have to like check every balloon. Let's see in net. You know what we could also do? We could also just hand the player to everything that needs to know where the player is. So like if we, instead of just making a player and then just shoving it into the ether, we could hand the player to our balloon machine, and then the balloon machine can kind of, since it's already iterating over its clouds anyway, it can keep track of where the player is. And there's only one central sprite for the player, so it can like flip a flag on it or something. Let's try that. So we're saving the player off into here, and then we are passing our player into balloon machine. So then our balloon machine is getting a player object. And then on update, so we have should make new. This is where we destroy the balloons and then call update on them. So we could either leave it up to the balloon and pass the player coordinates into the balloon, or we can just do it all on the balloon machine. Yeah, I like the idea of just handling on the balloon machine, but first and foremost, the balloon, we're going to need to be able to get the X and Y. So this is our balloon object here. So this is no longer going to be a local. That's going to be O.X and O.Y. Speed can stay as a local variable. We need to update U. We're going to need to update U. Okay, definitely not ready to run it yet. Line 118. I think we missed. Oh yeah, we missed right here. Okay, cool. So I haven't broken anything yet. Okay, we did break something. All of a sudden, man. Okay, there's a balloon. Back in balloon machine, we have access to our player now. And then let's make a function touching player. And we're going to pass in a balloon. That means bx is equal to player x, and by is equal to player y. So we'll do this. If touching player. Okay, so if our balloon is touching the player, it should pop. We're going to set destroy equal to true. That should be enough to let us know that this is working, because the balloon should disappear then. So I think in the interim we could at least make it look like our player is destroying the balloons. Not quite working. The balloons are actually going too fast. How about we slow them down a little? Speed equal to 1. Not quite working. Should make new touching player. Pass in a balloon. Bx is equal to player X and By is equal to player Y. Makes sense to me. Let's see if we ever get here. Touching. Never even get there. This will be interesting. How about we just log with an update? We just log the player's X and the player's Y. X, player X. That should be good enough. Okay. So inside of the balloon, we already know the player's X. That's encouraging. Here inside of the balloon machine. Touching player. So maybe there's something wrong with our touching player. This will be interesting. Let's see if we know the player's coordinates from inside of here. While I still have the chance, I'm going to change this to P. No, I'm going to leave that alone. Stay focused. Syntax error near return. Oh. Okay. So we know the player's coordinates. Do we know the balloon's coordinates? Oh, I see. It's because the coordinates are always going to be like a decimal. So I think it's saying, yeah, an integer is never going to be equal to a decimal. Interesting. Okay. Well, we learned a lot just now. And I think a quick fix would be when we randomize this, we can, to ensure that it's an integer, we can just throw floor on there. So now let's see if our collision ever happens. Well, I think this just fixed the world. Now balloon should disappear. Yeah, we did it. Boom. It's still kind of touchy. Sometimes it feels like I'm definitely hitting a balloon. And yeah, like those should have all been deleted. It's very touchy. It's very hard to hit balloons. All right, lots of good stuff. I'm pretty happy with this. Thanks for coming by. If you watched the stream, hope this was exciting. I will see you next week when we add stuff like sounds, lives, and try to turn this into a real game. All right, everybody. See ya.